All right. So yeah, thanks everyone for coming out. Like Butch said, he called and asked if we would graciously take the first event. So bear with us. There's not really anything set up yet. We're just kind of going off the cuff here and try to give y'all some information and just kind of touch on a few products that a lot of y'all probably have seen before. A few products you probably haven't seen before, and just kind of talk about the different types of cutting machines. I mean, everything that Mathey does is pipe cutting and clamping, beveling, centered around pipe, and also just round metallic stuff, right? So we deal with anything round and metallic. So it can be tanks, it can be vessels, it can be rail cars, submarines, I mean, you name it. So it doesn't have to be pipe specifically, okay? Mathey has been around in some form or fashion here in Tulsa since 1935. It started out, everyone's probably familiar with H&M. Well, that's Horder and Mathey. That was their original company. They split sometime in the early 50s, and then Mathey's been around ever since then in, like I said, in some form or fashion, kind of changed names a few times. So we're going to go over kind of Mathey first. So Mathey was founded in '36 by Mr. Chester Mathey. They focused on manufacturing pipe cutting systems using flame. Now, all of the cutting devices we have, they're a carrying device for a cutting torch. So they don't actually do the cutting themselves. Okay, so with that said, a lot of the machines can be used for other purposes, right? So we can carry, flame cutting devices, plasma, oxy fuel. We've carried water jet cutting torches. We've carried ultrasonic testing equipment, paint sprayers. I mean, you name it. We can pretty much carry it in some form or fashion. The traditional markets have always been the energy sector, primarily oil and gas. I mean, that kind of touches on probably 70% or 80% of the businesses in Tulsa, but that goes true for Mathey as well. So Mathey actually is the patent holder of the very first beveling machine, just like this one right here. A lot of people call these Oki bevelers. You hear them called just bevelers, but that is the original machine. It's only gone through 7 or 8 different design changes and updates, but the basic machine, all the main components are pretty much the exact same since 1935. Going into the saddle machines, so the saddle machines are portable. They're light, compact. They're accurate. They're easy to set up. They're proven. I mean, they've been around for over 80 years. Adaptable, so you can carry, like I said, you can carry oxy fuel torches, carry plasma torches. We even carried laser cutters with these. And built to last. We get saddle machines in for repair that were manufactured back in the 50s and 60s. And these machines are definitely built to last as long as they're taken care of. The range is 1.5 to 48 inch. They typically have a 4 to 6 pipe size range. They're sized to their max pipe OD. So like this is our 1SA, does from 3 to 8. The one that I've got over here is a CNC options, like our 1.5 to 4. So the largest one will fit around 48 inch, and it will cut 30. It's actually 36 to 48. With all the cutting machines, there's different accessories for different applications. So we have the regular torch arm that comes with the machine, but if you're cutting with plasma and you have a rack on your torch, then we have a special arm with a different torch holder to accept the torch with a rack. Because the standard torch holder there's not a slot for the rack there. We get a lot of pipe yards that have these, and when they're cutting and beveling or severing a section of pipe off for a customer, they want to do a cut and bevel on both sides of the joint at the same time. So we have what's called a double torch arm, holds 2 torches, and they can cut the pipe and bevel both sides, just saving them time and product, because they're minimizing their waste. And then like saddle cutting devices. So we have templates that get bolted onto the saddle machine with a spring-loaded arm. The templates are made such that they're only good for one type of cut. So a 4-on-4 saddle, or an 8-on-8 saddle, or if you're doing a T saddle, or if you're doing a lateral where the saddle's coming in at an angle. The templates are size specific and cut specific. So, but that is an option available for the saddle machines. This is the last slide on saddle machines. The last thing here is our plasma speed. So this is the tried and true saddle machine, right? This is the original one. What most of y'all are probably familiar with is the hand crank here. So you hand crank it around. It has 2 drive gears that are driven by a chain. Okay. So we get a lot of questions. Well, can it go all the way around even though the bottom is cut out? Well, yes, it can, because that's where the 2 drive gears come in. So as one drive gear loses it, the other one still has it. And as it goes around, then the other one picks up the ring gear, and then the first one loses it. Okay, so that's how this machine goes all the way around and makes a full cut. Okay, now if you're changing this to go down to a different pipe size, you just change out the spacer bolts or the dogs, the feet, and the feet are size specific to the OD of the pipe. Okay, the reason they're sized to the OD of pipe is so that when you have a torch, the torch tip to pipe distance stays constant all the way around. So you're centering the machine to the pipe. Okay, that way you don't have to move the torch up and down. Any questions on the saddle machines? Okay, the last thing I'm going to touch on is the new plasma speed. This is our new motorized saddle machine. So if anyone, and a lot of times this is what's used in the fab shops. But what we've done is, so the older motorized machines had a Baldor DC motor, had a rheostat control box, and as it was going downhill, it would go down fast, and when it came uphill, it would slow down because of gravity. Okay, so what we've done is we've redesigned all of our motorized machines to use a digital control box with digital stepper motors. There's a lot of advantages to doing that. There's the constant speed, so you have a much more consistent speed all the way around, so no more fast downhill and sluggish uphill, which is only going to improve the quality of your cut. You have a much more refined speed control. You have a daylight LED readout, so you can see that in direct sunlight. You have an e-stop, that's standard for all the machines. And then if you happen to trip the circuit breaker, you don't have to try to find a fuse. So the old one had a fuse. So if you blew a fuse, then you were out in the field or even in a shop trying to find a fuse. So now we've changed that over to circuit breaker. This is our plasma speed. It's just the name of our motorizing strategy. But then this control box, our older one, which excuse me real quick. Yeah. This is our old control box, which we only use it on this one machine now. But this right here, if you drop it, it's pretty much toast. It's only going to last one drop. It's not very robust. So with this, we've made it drop proof. It's IP67, so it's good for water, rain. You can be in a dust storm and use it. So it's not going to deteriorate like the old controller. Okay. And there's magnets on this one, which was always a request on our old ones, to have a magnet to put it on the pipe so it didn't fall off. Any questions on saddle machines?
Typically, are you cutting and beveling in one step, or are you?
Just depends on your prep, right? So if you have a butt joint, you're going to be doing a 90-degree cut. If you're a pipe yard and you're cutting off a section, it's going to be a 90-degree cut. Typically in the field, it's always going to be usually a bevel and a cut. And Butch, I mean, you guys can probably tell. Yeah, I would say in the field, it's almost always cutting and beveling in one step. Correct. With each of the different torch holders, they all will hold the torch and allow you to cut and bevel in the same holder. They just may do it a little bit differently. So this one, when you loosen up the torch holder, and you can pivot it, and then by loosening the clamp on the torch, then you can raise and lower it so that if you're doing a 90 degree versus if you're leaning it over and doing a 45 degree bevel. So whatever the joint prep calls out, that's what's going to dictate if you're cutting and beveling or just cutting. Sometimes what they're wanting to do, or what they'll do, is they'll cut it off, and if they're cutting a small pup joint to put in, if they don't quite know the exact finished length, they'll cut it just a little long, get it out to the field, and then they'll use our beveler in the field or using oxyfuel to then cut it to the exact length once they know exactly how long they need it. All right, so the next thing is our CNC saddle machine. So we introduced this right at 4 years ago. When I first came on at Mathey a little over 5.5 years ago, we started the development on this. The first CNC machine actually was in the early 80s, and you had, just like an old NC machine where you had cards that were punched and you fed them into the reader. Well, they had that on a pipe beveler, but you had to know G code. You had to actually know the G code, punch the cards, and then feed it through. Well, obviously that's not very conducive to the normal welder or pipe fitter or engineer, or that's a dying breed of CNC machinists anymore. So what we did was we came out with our portable pipe CNC. So it runs off of a standard laptop. This one we have here set up is our MSA model, so it's 1.5 to 4. We have a 3 to 8 inch model and a 6 to 12. Okay, the package, it comes as a CNC package, so it's not an addition that you can add on. If anyone kind of wants to kind of migrate this way a little bit, I'll talk about it over here, and then when we get ready to cut, then we'll kind of back off a little bit and we'll get around. So all the machine is made of aluminum except for the main cover right here, which is steel. Everything else is made of aluminum, so it's lightweight. This package fully put together is sitting right about 37 pounds. It's very field portable. I have several of these being used by rig welders running around making saddle cuts for test pipe. I've got these all over Canada, North America, Russia. We have them in, I think, 19 countries now, and they're used in fab shops, outside, inside, cold, hot, humid, you name it. Okay, we've really designed this to be as field ready as possible. All the electronics are isolated, they're potted, they're encapsulated, so they're ready for moisture, they're ready for basically whatever the elements can throw at them. So the actual mechanics of it, now it is a 2-axis portable pipe CNC, so it's not going to replace a stationary pipe CNC, a bed style that's inside of in a shop. Those are always going to have advantages. It's going to have they're going to have longer stroke. They're going to be able to rotate the pipe, which is good and bad. There's safety issues with rotating the pipe. So all of our cutting machines, the pipe is stationary. That's really to help. So if you're using it in the field, then you don't have to try to rotate the pipe in the field. So the CNC can accept, there again, oxyfuel, plasma. We haven't really done it with anything other than oxyfuel and plasma, but it's not to say you couldn't. So with the CNC machine, we have a couple different options. Well, one, so it runs off of the standard laptop with a regular old USB cable. The power cable that goes in the side is a desktop PC power cable. So if something happens to it in the field or whatever, you can find them at any Walmart or Walgreens or anything like that. So that's nice. The only proprietary cables are the yellow power cable that powers the arm, and this gray cable, which is going back here to the plasma machine, and that's what will auto fire the plasma cutter. So the operator doesn't have to try to control the plasma in addition to the machine. So the machine will fire the plasma and turn it off and control the whole process. It's infinitely, it has 1.6 billion cuts in the standard software. Okay, so it'll basically do any kind of normal pipe joint that you have within the 1.5 to 4 inch pipe range. This one will cut up to 4-inch. So you can do like a 4-inch branch on larger pipe, but you can't physically cut larger than 4-inch with this machine. Yeah, we have 3 models. 1.5 inch. This is the 1.5 inch to 4. And we have a 3 to 8, and then a 6 to 12. And 12 is the largest we have. Yeah, because our patent is for a portable pipe CNC, and once we went to our next larger size, it was no longer portable. It became more than OSHA 2-man carry, which was our definition of portable. So then it was over 100 pounds. Okay, good question, good question. And the software, I mean, obviously trying to see the screen is going to be a little difficult for everyone, but if anyone wants to see the software as afterwards, or we can run through and see as many cuts. But the software is really kind of where the magic happens, because the software is designed to be super user friendly. It's in different languages, so if your shop hands are, we have it in Russian, German, Spanish. We have different languages based on whatever the needs are for the users. Okay. I'm just going to kind of do a quick hole, just to show the motion of the machine, and then we can do other cuts later. Like I said, if the software is like I said, just extremely user friendly. It's all picture based. It's like a wizard. It asks you questions. It's got pull down menus, and it really just is conducive for people who aren't very computer savvy. So I'm just going to do a dry run just so everyone can kind of see how the machine operates. So right now it's just doing a 2-inch hole right on the top side of the pipe. I can move the cut in and out along the arm. The arm has 14 inches of stroke, so it'll do any single cut and any bundle of cuts within that 14 inches. So if you have multiple holes for threadlets or port holes or saddle holes or whatever you might have, as long as they're in the 14-inch range, then you don't have to move the machine. And then it will clock around. So
I got 3 holes in 3 different spot locations.
Yes. So how I normally do it is I use our center finder, and I find top dead center on both sides, both ends of the pipe, mark a common center line. So that way everything's referenced off a common center line. That way if the pipe has to move to a different shop, a different weld booth, or if the pipe rotates, you're not having to try to find that center. So you start out with that, and then the pipe fitter still has to know how to lay out the different holes. I mean, you're not taking the pipe fitter's job completely. You're just making it a little bit easier when it comes to the actual cutting process. So you can lay out those different holes, and then within the software, you can tell it, clock over at 15 degrees this way, and out 7 inches. And then if you know that you need to come back 2 inches and over 30 to make the second one, then your second cut is not minus 15 and only 5 inches out to the center. So you can mathematically tell it angles and position.
Is that all in one program? I mean, you don't have to do like weld first, whatever you're going to do.
You set them up individually.
Okay.
And then and then we have a sequential cut where you bundle them together.
Okay.
And you can bundle all of them or just a couple of them, or you can bundle 100 cuts together if you really want to. Within 14 inches, or not to overcomplicate it, but there are some different shops. I'm actually working with one in Abilene right now that bought this size machine, and they're running 3-inch pipe through it on roller beds, and they just put stops. The machine stays stationary, and the pipe hits a stop, and then it makes a certain cut. The stop drops down, it moves to the next one, and then they make another cut. So the machine thinks that it's never moving, so the pipe is physically moving. So they bundle, based on 10 pipe joints, they bundle 100 cuts within those 10 pipe joints, and they just feed the pipe through. And the machine never moves. I mean, it moves around, it moves in and out, but it doesn't actually physically move. Well, MSRP is around 15,000. So if you look at it based upon a 2-axis stationary machine, that's, let's say, a 2 to 12, they're going to range about $100,000 starting out, not including the fact that you have to have a CNC programmer to run it. So if you had all 3 size machines, you're in MSRP, you're in about 45,000. It's less than 40. So but you have your pros and cons. I mean, this you can take out to the field, and stationary machine, this you can go to the weld booth in versus the stationary machine where you have to take the pipe to it. So I mean, there's obvious pros and cons to every type of machine, but this feels kind of a niche that's never had a machine for. It works really well for smaller shops that one may not have the capital, but need gives them the accuracy and the efficiency of a CNC machine. So it has its place. May not be everywhere, but it does have a place in a lot of different shops. You want to cut it? All right. So safety first. So if you don't have any shade 5s, don't look at the arc, please. Yeah, it'll do pipe to pipe at an angle, like a lateral. It'll also do pipe to like plate, which would be like a miter cut. Or if you're doing a mitered elbow and you had to make multiple angled cuts to do they call it a mitered elbow, but I'm not sure what all. But yeah, it'll do all those normal kind of pipe shapes. Once again, don't look at the light. All right, fire and hole.
Cleaner than what I've been done with that.
Right.
That's nice.
Very good.
That's a lot faster than I thought it would be. What wall thickness is that pipe?
This one, about 1/4 inch.
Is it? Yeah.
But the pipe wall thickness that it'll cut is only going to be dependent on what you're cutting with, right? So if you're cutting oxy fuel, this would be like an aught tip. Well, if you're on 1 inch thick, let's say you're on 8 inch or 10 inch, you're on 1 inch thick, you just use a number 1 or number 2 tip, right? So you change your cutting tips, and the same thing with the plasma is, I'm sitting here at 70 amps. I may want to go up to 85 and run a little bit slower. If I was on, 1 inch would be maxing this one out for plasma, right? So you change your cut speeds and your consumables, or maybe your tips if you're running oxy fuel. You just change that to accommodate the pipe size or the wall thickness. So kind of the next machine we're going to talk about is our Mini Jolly chain machine. So our Mini Jolly, I've actually got it sitting back over here on the table. But the Mini Jolly is a machine. It's a chain machine. It's driven by a double row cotter style pin chain. It's good from 2 inch, as large as you need to cut. Okay, that's the advantage of this machine, is you have one cutting machine and you just add chain or subtract chain for whatever pipe diameter you're doing. So this is really popular in vessel shops, where today they're cutting a 5-foot vessel or a 6-foot vessel, and then tomorrow they're cutting a 12-foot vessel or an 18-foot vessel. Same thing with pipe supply houses. So if a pipe supply place is cutting, 60-inch pipe today, 24 tomorrow, 36 in the afternoon, and they need to be able to use one machine that's easy to set up, and it's not necessarily the fastest machine to set up, but it is, easy to set up. It's durable and rugged. I mean, these have been used in the field. These are used on pipe that's vertical, pipe that's horizontal. You name it. It's a very, very versatile machine. Anything above 18 inch, and we recommend guide strips, that's just going to improve the accuracy of the machine, because as you know, pipe is of round shape. Vessels are of round shape, but they're not necessarily round. So if you hit a depression, it's just going to walk off into the depression just like your tires do when it hits a pothole. It's going to run off towards the pothole. Well, that's the same thing that this is going to do. In fact, most machines are going to do that, with the exception of the saddle machine. All right. So this is the double row cotter style chain. Every single link is a connecting link. So that's where, you know, you don't have to try to find one spot where you're connecting it together. Whenever you're changing pipe sizes, you just break it at wherever you are, take the chain apart, move it to the next size, and if you're moving from pipe size to pipe size where it's the exact same, then, you know, 4 or 5 minutes and you're moving from pipe to pipe. And even can be less than that. If you're changing pipe sizes, just depends on if you know how long the chain needs to be, which we have formulas. We have a calculator on the website, which you just put in your pipe diameter that you're going, if you're going from one size to another, it'll tell you how much chain to add. So we try to make it as easy as possible, but this is kind of the lowest cost of entry machine into pipe cutting. But in all realities, it's really kind of one of the most versatile. We have stainless chain and stainless wheel kits. So there again, you won't be, you know, if you're working on stainless vessels, you don't have to, you won't worry about marring the surface or cross contaminating. This one comes standard with the torch holder that will accept a rack. So if you're running oxy-fuel torches, you can run it with a rack. If you're running a plasma torch, then there's no additional accessories that you need in order to run those cutting devices. Any questions? All right, next one is a band crawler. So if anyone's worked pipeline, this is the probably most commonly used and most widely known cutting machine in pipeline. It's used in pipeline because of its low clearance, and it's easy to set up. I mean, one person can set up a 48-inch band, put on the crawler, and be cutting in a matter of less than a minute. Okay, so it's very, very easy and simple. It's the band will conform to the outer round of the pipe. So there again, since pipe is not perfectly round, you know, you can have as much as 4-inch of ovality difference, and it will conform to the shape. Kind of the other competitors of ours have these, and all the different machines kind of fit. They're all interchangeable with each other. So CRC Evans and Sawyer and some of those other guys, they have the same kind of transmission beveling machine here, and all the machines kind of work with each other. They work on each other's bands, so it's a very versatile machine. We've adapted our Plaza Speed digital control onto our band crawler as well. So you can, in the field, you can have that precise motion with the new control box. It's the other nice thing about the Plaza Speed motorizing strategy that we've implemented is it's very low power consumption. So all these machines can run off of like a 1500 watt inverter from your cigarette lighter, and that'll run all of the motorized machines. So you don't have to have a generator, you don't have to have, you know, auxiliary power. It's very, very, very low power consumption. So this is the one that most everyone knows is the hand crank model. Now this one, the other reason why it's used mostly in pipeline, like I said, is because of the clearance. Well, the reason it has low clearance is this is the only machine where the torch is parallel to the pipe. Okay, and then you use an angle head adapter to get the torch to turn towards the pipe. Okay, so I know it's kind of hard for everyone to see, but there's a boiler tip or a stub nose, or it's called about 100 different things, but it's a Series 108 Victor style tip. It's stubby so that whenever you turn it, it's the only tip that you can turn 90 degrees and still do a straight cut with no bevel on pipe. Okay. You release the torch. You can move the torch. You can move the torch to your cut line just by releasing the donut. And then if you rotate the donut, or elliptical torch holder, which most everyone knows is a donut, so that's kind of the industry term. But you can rotate the donut, and that will raise and lower the torch. So that's how you get your torch tip to pipe distance. Okay. Now I can still use a standard 101 series acetylene torch tip in this. It's just it's about a 2-inch long tip, and so it'll only produce bevels in this configuration, even with the torch, you know, all the way up. Okay. We have accessories for the band crawler to also accept the plasma torch. Okay, so if you're using this, if you have one for the field, but you also want to use it in the shop and use plasma, we have the accessories to be able to do that as well. Now, the last thing on the band crawler is actually our newest patent that we just got here about a year and a half ago is on our beveling bands. So if anyone's ever used this, when the crawler is crossing over the gap, so where the two band ends come together, when it's crossing that gap, it wants to wiggle a little bit because you have two wheels that are going to hit the gap at the same time, okay? And when you have the tendency where the crawler will actually walk off the band, okay? So what we did was we made a staggered gap. Okay. So we put this curve in the band end. Everyone see that? So that notch is extremely important. What that does is it allows 3 wheels on the crawler to always be touching the band. So as your 2 front wheels are coming across, this first one is crossing the gap while these 2 on this side and this back one are touching. Then when it grabs the other side, then the other side is crossing the gap. So you're always going to have 3 wheels touching the band. So it eliminates that crawler from wiggling and having the tendency to walk off the band. Well, let's see. They've been trying stuff for 40 years, and it was that simple idea right there which took care of the problem. I mean, really, something that simple. But really, I mean, but you know, that's usually how it goes. And look, you don't want something that's going to be overly complicated or that you have to do something to get it to cross the gap, right? I mean, so something as simple as this, you know. Now the other thing what this allowed us to do. So before, when your pipe OD changed, you only had to have a 1/16 of an inch of OD change, and then the band was now, you couldn't cross the gap. The gap was too wide. So with this, I can now have the pipe OD changed by 3/16 of an inch, which allows for pretty much all of your different Powercrete coatings, any kind of epoxy coatings. So now this one band works for a much wider range of pipe ODs. So it just gives you basically it gives you 3 bands in one. What used to be 3 bands. This will now cover that same range. So I wouldn't really call it necessarily, you know, I mean, when you think of size, you know, expandable, you think of like 16 to 20 inch, but this is really like 16 to 16 and 3/4, or 16 to 16 and 3/16 OD change, which in the band world, that's actually quite a bit.
So does that band now cost 3 times as much?
We actually dropped the price. Because what we did was when we did that change, we were able to go to like cut bands. We changed our manufacturing process to actually reduce the cost, and then we reduced the price to the end user. That's right. That's right. Yeah, I cut that off, so I saved y'all at least 30 cents right there.
Not even that.
No, but we did. We dropped the prices over 10% across the board whenever we implemented our new design. And we just phased out our old design and just completely went to this design. Because really there's no advantage to the old one anymore. And it will get your fingers if you're not careful. So, all right. Any questions on band crawlers? This is also, one last thing is, this is the machine to use if you're doing vertical pipe. So if you're driving piles or bridge supports or anything like that, this will go on the vertical pipe, and this also is your track so that your cutting machine doesn't spiral down the pipe. So with any of the other cutting machines, the that machine you can't put on vertical. Well, we don't recommend it on vertical pipe because it's got a spring-loaded boomer, so it'll fall away from the pipe. Not to say that people don't do it, but we don't recommend it. And our chain machine, if you put it on vertical pipe, then it'll just spiral down the pipe. So the band crawler is really the best machine for cutting vertical. So we have two different magnetic machines, a MagnaCut and a Mini Mag. This is a magnetic carriage. It uses rare earth magnets. We use rare earth magnets so that the other alternative is electromagnets. So if you're using electromagnets, you lose electricity, the machine falls off the pipe, which it's carrying a live cutting torch, and you really don't want to slice somebody up on the job. So we use rare earth magnets so that if you lose power, the machine just stops. Okay. I'll show you right here. It also has the torch holder that will accept a rack, so you can angle the torch to produce a bevel. You have your speed control. It does, and there is no hand crank option for this. You have to have electricity. So this is used a lot of times in a shop setting. So each set of magnets and each wheels has 150 pounds. So if I just go try to pull it off, I mean I can break it loose, but if you notice, I broke it loose pushing up on the arm, because that's its weakest point, because it's only touching, effectively it's only touching in 4 lines, right? So if you break it from the side, it's a lot easier than trying to pull it off. And so when you're installing it, so you put it on sideways and you twist it, and it will hit a point, and it's locked in. So then what's nice about this too is I can do a running pierce, so I can pierce and then come back to my cut line, so that you don't have that blowhole or that pierce hole right there on your cut line. So then once you finish, you can move off, or you can just kill your torch, and then you'll have a nice smooth cut line. Within a 1/16 of an inch on 20 inch and below. And then 20 inch and above, we have guide strips. So these guide strips, well, they bolt together, and this runs in between those guide wheels. So you bolt this, so you use a wraparound. If anyone's familiar with the wraparound, so use a wraparound to get a square line. You mount these to that line, and then you mount the machine over the guide strips, and it'll cut straight. This is also how you cut vertical pipe with this machine. So you put these on, and then this provides the support so that the machine doesn't, there again, spiral down the pipe. The difference between a MagnaCut and our Mini Mag, the MagnaCut actually has a motorized torch arm, where this is the Mini Mag, which you have a manual torch arm. It's about a $4,000 adder, but if there's instances where you're on large vessels and you don't want to have a guy or have a person up on top, you have a control box where you can move the torch in and out. So there's advantages. This is also the only machine where you can cut from the inside of the pipe. So if you think about it, when you're building, let's say you're in a pipe rack and you have no clearance around the outside, on 20-inch pipe and larger, you can put this on the inside and it will cut from the inside out.
What are we going to see in that position when you cut inside a 20-inch pipe?
Well, typically you'd run the torch out to the end, because you're cutting the inverse, right? So when you're wanting to do a bevel, let's say I'm trying to bevel this side. On the outside, I want it to bevel like this. So all you got to do is turn your torch in and then rotate it down, and there you go. Now you're doing a bevel, the correct bevel from the outside, but you're doing it from the inside. This is also how a lot of vessel shops do it, because when they rotate, so they'll put the vessel on rollers, they'll put this in the bottom, and they'll just have a guy standing, right there at the bottom. The machine will run with the vessel, so it's staying right there at the bottom. So it's also, I mean, this is a very versatile machine. All the machines are versatile for different, they're used in so many different applications, just how you use the machine. All right, so the Dearman side of the business. So Tim Dearman started in 1970. His first patent was actually 1967 for the first pipe chain clamp ever invented. They're again focused on manufacturing pipe clamping systems, including flange and layout devices, and also, traditionally serving the energy markets. This was the first commercially recognized pipe clamp from 1973. So this is actually a 798 Union welder here in Tulsa. He's put out over 300 of these cartoons, and they're all really cool because, I mean, look, everyone's, at one point in time, you've seen a whole bunch of stuff being used that probably shouldn't have been used, right? And if you ever go to try to cut some of these things apart, you don't want to be standing anywhere close to it because, boy, it's going to spring apart like so, like no one's business. So, yeah, so this is just kind of a neat little illustration of, I guess, what not to do, right? So we have, I'm going to run through this fairly quickly because I know I don't want to run here till 9 o'clock. But so the chain clamps, there's single chain clamps, there's double chain clamps, there's single jack screw, double jack screw, and they all kind of serve different purposes, but they all do the same thing, as they clamp two sections of either pipe or pipe to fitting together for the welding process. Okay, so once you get your Mathey cutting machine, you've made a good prep. Now you pull out the Dearman clamp and you fit it back together. Okay, this is going to be a good alternative, obviously, to weld on dogs, or using nothing at all. Having someone hold, an elbow or hold two pieces together, and you're tacking, and then you're cutting tacks, and so this really kind of gives you a really good option for doing your alignment, and then also every clamp is going to do a different level of reforming. So reforming is taking ovality out. Now we're not re-rounding. So everyone wants to re-round pipe, but you don't really need to re-round. You're either going to take a round section that's mating to an oval, and you're going to make the round oval, or you're going to make the oval round, or some form in between. So you're just wanting to mate the two ends together, whether it be pipe to pipe or pipe to fitting, pipe to flange, whatever it is. Okay, so every clamp kind of has different levels of alignment capabilities and different levels of reforming capabilities. So as you get into the double chain, you get into heavier wall thicknesses, heavier tensile strength pipe, and then as you get even, then on the other end is our mini fit, which is for like tubing and electrical conduit, aluminum pipe, stuff that doesn't have a whole lot of, you don't need a whole lot of force to do reforming. It's also small, lightweight, can get into tight spaces, so there's advantages. Dearman sleeve clamp. So this is a variation of a Dearman chain clamp that's used to put on hot tap tees, stopple fittings. If anyone's familiar with TDW, you have stopple fittings, you have hot tap tees, you have pipe sleeves. So if you're running a pig and they find a deformation, whether it be a crack, a dent, some type of anomaly that's not supposed to be there, if they don't opt to cut it out, then they may opt to sleeve it by using two half-sole sleeves. They put it on the pipe, and then they weld down the longitudinal seams and then around the outside seams. And our sleeve clamps are hydraulic clamps. They use the chain to actually compress the sleeve to the pipe. So this was kind of a purpose-built clamp for integrity work. Our super clamp. So this is our newest clamp that we came out with. This came out about 2 years ago. This actually does aligning, reforming, and also does gap control. So when you clamp this on the two ends of the pipe, it has turnbuckles, different number of turnbuckles based on the diameter, and you can actually pull the pipes together. Now obviously the pipes have to be free-ended. They can't be constrained. So we're not stretching the pipe. This isn't the elusive pipe stretcher. But so a couple of our customers, particularly Kiewit is one of them that's adopted this clamp across the board. And so if you think of it, if there's two pipe joints and then the pipe goes up and over walkways, getting that one weld, that one field weld is pretty, it can be hairy sometimes, getting that to line up. So they're using ours to be able to pull the pipe ends and do the alignment, and it drastically reduces the amount of setup time in that type of installation, and also in tie-ins. So tie-ins are also another point where you kind of never know where the field pipe is going to end and where the fabricated joint is going to start, and so having that gap control is very important. It works on carbon steel, stainless. It works from pipe to pipe to fitting. What's that?
How large a pipe?
The largest super clamp we've done so far is up to 56, but theoretically we could go as large as 12 foot would be a conservative stopping point. You laugh. We get a lot of applications. Small pipe to us is anything under 48 inch. Rim clamps. So these are the bad boys. These are the big bad boys that are for heavy duty reforming, heavy wall thicknesses, high tensile strength pipe. This is if your pipe is ovaled and it's, let's say P91 chrome 80 inch and 1 inch wall, and you're trying to take a quarter inch ovality out, which doesn't sound like a lot, but when it's P91 chrome, that's a lot. So we'd make these all the way from 4 inch, and we've done these up as large as 120 inch. And then our mega rim clamp for even thicker wall thicknesses and even higher tensile strengths. We've done X110. We did a job over in Nigeria. It was a 2 inch wall on 96 inch pipe. And we actually took a 16th ovality out, which doesn't sound like a lot, but on 2 inch wall, that's pretty impressive. They were 16th out of spec. So they just needed a 16th, so we were able to provide them a 16th. All right. Cage clamps. This is pipeline. These are called Tipton style clamps, breakover clamps. They have a lot of different names, but they're size specific. They're typically used in attack style formation where you have straight crossbars, which I have one sitting right over here. So these are used just to do real simple alignment. You do attack in between the crossbars. They also have versions of these that have, hoops to be able to do a full weld out with the clamp in place. But they are size specific, and we have these in stainless as well as carbon. And then there's the ratchet style, which on pipeline they do breakovers between up to about 16 inch or hand levers like this, 16 or 20 inch, and then they switch over to kind of ratchet style. Well, they'll have a ratcheting device here where you get a wrench and it pulls it together using this ratchet. And then they also have hydraulic versions, which is really more used overseas traditionally. But these are, we've done these up to 72 inch. But they're kind of the low cost of entry clamp, I guess, for pipeline. But they're also, what's really nice for pipeline specifically is the low clearance. The only part that you have clearance issues is the handle. So when it's up, that's your highest point. But usually the clearance is really on the bottom side, or if it's in the ditch, right? So the least amount of dirt they have to dig out around the pipe is going to save time and money. Okay. Quick fits. I've got one sitting over there. It is alignment only. There's 3 models to go from 1 to 12. Can be used on carbon or stainless. And this is great in tight spaces like in drop ceilings. I have a lot of mechanical contractors that use these. They flip it upside down to where the lower feet are on the top side, and you can screw from the bottom. So these are really, really good for that. They also fit in a toolbox real nice, and they're lightweight, but they don't do any reforming. So they're only going to be for simple alignment of two pipe joints. And then a full range of jack stands. We have the green, the OSHA safety green. They're high vis. We have 4 different models: a tall folding, a short folding, a regular fixed leg, and then these 5-legged rolling stands with different accessories for ball transfers and roller heads, and then different pipe fitter tools. I mentioned the pipe wrap. You got the centering head for finding top dead center, protractors, welders gauges, and then a full range of alignment tools. So this is for internal flange alignment, for flange spreading, used in like turnarounds. Flange alignment pins or flups, or 2-hole pins. This is obviously for 2-holing flanges. We've got 3 different models. 2 that are aluminum, or 2 that have stainless cones, and then 1 for carbon steel. And they're all of ours are quick release. The carbon steel one's a push button, and the 2 stainless models, one is a wobble nut, where you slide it on in a couple turns and it's tight, and the other one's a slide lock. It's got a button that you slide it on and off with. And then a full range of spacing wedges. And the last thing is our coupon cutter. This is for strap cuts for weld testing. And we've got one down at the other end of the pipe there.